All right, so I am the bearer of good news and bad news. The bad news is we are already on module 14, and we're going to cover two additional modules this week, so 14 and 15. The good news is neither 14 nor 15 carries any additional assignments with them. So we're going to cover two modules this week that I would consider more important if you are interested in computer science, um, and maybe more of a category of just kind of interesting and probably somewhat forgettable if you're just wanting to learn basic programming or some just hard software development skills without computer science so much. Although I will say that today's topic, algorithms and algorithm development, will strengthen your ability to problem solve when it comes to even some of the previous assignments for this class. And honestly, algorithmic thinking is something we've been doing in this class in a lot of ways already, without using the fancy terminology. And of course, if you start throwing around the word algorithm, you might sound smart, or you might sound one of those folks. You might sound like one of those folks who thinks Facebook is out to get them, or YouTube is out to get them through some magical tracking mechanism called the algorithm. And the algorithms that we're going to talk about today do have a commonality with the algorithms that you'll see on Facebook or YouTube or any of the other social media sites, in that the algorithm on those sites is essentially just trying to figure out how to get you to continue to pay attention to those sites. And it does that using your past behavior. So if you watch a lot of videos of, let's say, cats, then it's going to show you more videos of cats. So maybe you've had the creepy experience of shopping on Amazon and then clicking over to Instagram only to find that the thing you were shopping for on Amazon is now magically showing up on Instagram. There's nothing that complicated about it. All that means is that Amazon, or one of its subsidiaries, is paying for advertising space on Instagram and is using their own algorithm to try to discover what it is you're most likely to buy based on the things you've been looking at, and using that to target their advertising to you. So it's using data as a process to solve problems. Now, specific to this module, when we say algorithm, we're basically saying a step-by-step procedure for solving a problem. So when we talk about social media algorithms or advertising algorithms, the problem is how to get you to buy more stuff or stare at the screen a little bit longer. And the step-by-step procedure that they're using in 99% of those cases is, let's keep track of what they look at and let's compare it to what other people liked who look at similar stuff. So if I'm looking at cats videos and my cousin is looking at cat videos, but also buys a stuffed cat on Amazon.com, then Amazon is likely to show me that stuffed cat because somebody who looked at cat videos was more likely to buy that stuffed cat than somebody who didn't. That's all it means. It's just forming basic associations. And it's very similar, honestly, to the way that artificial intelligence is trained, by forming those bonds and associations between things. So in this class, a step-by-step algorithm or step-by-step procedure for solving a problem might be something like, how do I list all of the prime numbers between 0 and a user-generated number? So we would take that and we would look at that problem and come up with steps that would allow us to solve that problem. The steps in creating an algorithm, or an effective problem-solving strategy, in other words, involves these three things, right? Deconstruction, solving the deconstructed problems, and reconstruction. In other words, if we have something that looks like the figure on the left here, where we've got a problem with problems inside it that have more problems inside that, the way we would approach this complex problem is we would start taking it apart. We would take the smaller problems out and we would break every little piece of this down into the smallest possible components. And then the next thing you would do is you would start looking at those individual components. So you would solve each little problem as its own individual problem. And then the last part, reconstruction, is just putting it all back together. And by that time, you've achieved a more cohesive solution. A lot of times, solving these little mini problems, once we've broken it down, is a good opportunity for us to create functions. And then when we put it back together as a one cohesive program, it's actually not that complicated, because something that seems complicated in context, when written as a function, is actually quite simple. So I'm going to give you some examples of this in just a minute. But there's one more thing I want to talk about, and that is pseudocode. We haven't really spoken much about pseudocode in this class, but pseudocode is just a way of using regular descriptive language to represent code. So it's a way of thinking about programming before you actually start programming. And we haven't mentioned the word pseudocode, but I've encouraged you to use comments throughout this class to sort of plan ahead and think about how you want to solve the problems of a program. And so pseudocode, or the idea behind pseudocode, is that you're writing the comments first to say, here's kind of my plan. Does it make sense? Am I breaking down the problems? And if you get into a problem, like say printing out the numbers from 1 to 200, sometimes you know the code right away. Sometimes that becomes another problem where you say, well, this would be simpler if I could break it down a little bit further into smaller problems. And you just keep doing that, breaking down problems into smaller problems until everything is solvable. And then from that point, you should be able to solve the larger problem. So let's take a look at code. So if I wanted to find all the numbers, find all prime numbers between 1 and x, with x being something that the user gives, and x would be an input. Yeah. So how do we know if something is a prime number? Let's look at the really basic problem. What's a prime number? It's not divisible by 2, actually. It's divisible only by itself or 1, right? Only by itself and 1. So divisible by 1 and x. Okay, good to know. So to find out if something is a prime number, let's say is 11 prime, I would need to divide it by 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And if that number 11 is divisible by any one of these, then we know it's not a prime number. So if I want to find all the numbers between 1 and x, if x is 11, then I'm asking, is each one of these a prime number? And what that means is I have to, if I'm looking for, is 5 a prime number, I have to look at 2, 3, and 4 and see if those are divisible by 5, or 5 is divisible by those numbers. So there's a certain loop inside a loop here. But let's start with a basic block. Let's break this down into its components. So the first thing I need to do is I need to be able to tell whether something is prime or not. And so let's start with that. Int input equals, I'm just going to change it to an int on the fly, enter a number. Okay. And now that supplies me a number, and I want to see, is that number prime? So what I need to do, if the user enters a number, is I need to check and see can this number be divided by any of these numbers between that 0 and that number evenly, or 1 and that number evenly. So what's the easiest way to find out if a number is divisible by another number without a remainder? You remember? From early in the class, there's actually an operator that does this for us. Anybody remember? Modulo, yeah. It's the percentage sign. So what I would say is for int test in range 2 through int input, and I'm going to say if int input modulo int test equals 0. In other words, if this divided by this has a 0 remainder, then we know it is not prime, right? Because that would mean that we have a not prime number. Okay, so what I want to do is I'm going to set a variable flag that's Boolean. I'm going to call it Boolean prime, and I'm going to say we're going to start that out as true. And if I find out that it's not a prime number, I'm going to switch that to false. And I might as well stop trying, because once I find out that it's not prime, it's not prime. I can't, there's no use in even doing more tests after that. Okay, so that's pretty good. And I can do else. Well, actually, once I get done with this, if Boolean prime equals true, then print it is prime. Actually, let's print the number. Int input else print input is not prime. Okay, so either it's prime or it's not. Not sure why I'm doing that. Okay. So let's try this out. Let's see if it works. Okay, so 7 is a prime number. Got that one right. Let's try something that's not a prime number. Let's go 8. 8 is not prime. 9 is not prime. Skip ahead to 11. 11 is prime, so we're good. So that is how we get the answer to whether a certain number is prime or not. Now, that's not what the assignment is. What the assignment is we want to list all of the numbers that are between 1 and x that are prime. So we're only part of the way there. But now that I figured out this basic building block, what I'm going to do is I'm going to make this into a function. So define is prime, and let's do that. Int number, and there we go. And the final thing we want to do here is return Boolean prime. So now, if I give this function a number, I've got to make sure that I'm putting that there. There we go. Now, if I give this a number, it's going to spit back true or false depending on whether it is prime or not, and it's also going to print out whether it's prime or not. So now I have one of those building blocks, or one of those mini problems solved. So now I just have to go, if the user enters 11, I just need to ask, is this prime, is this prime, is this prime, is this prime? Well, that's easy to do now. So after the input, I'm just going to cycle through those numbers for int test in int input. Oh, I'm doing a range here. That's what I'm doing. Range, and I want to find all the prime numbers, 1 to that number. Okay. And I want to say, if it's prime, I'm going to store it in a list so that at the end I can print out that whole list of prime numbers. So I need to create a list, AR list, AR if is prime, int test, then add it to the list, AR list append int test. And then when I get to the very end, I'm just going to print out the list, print AR list. Okay, so after I broke that down into the basic problems and solved the prime number piece of it, okay, so if I enter 15, it's going to go through, look at each one, decide what's prime, what's not prime, and then it adds all of the prime numbers to the list and prints it out. So I could give this any number that I want, and now I can generate a list of all of the prime numbers between 0 and that number, or between 1 and that number. Notice 997, so just 2 away is a prime number. That seems like the bigger numbers get, you would stop finding prime numbers, but that's not necessarily true. The interesting thing about prime numbers is that they go very, very high. In fact, if I put in 10,000, we get a little bit further, but 9,973 is a prime number. So kind of interesting, I think. And it, of course, will list them all. I could literally put any number I want to in here. And what you would notice, if we put in a really, really large number, probably in the 100 millions or something, by the time you get to those high numbers, it's having to do so many calculations just to test whether that number is prime or not, is that the program would actually slow down a little bit. So you would actually visibly see that happen. It would take a very large number though, because the calculation that it's doing is very simple. So that's an easier or simpler application of our of algorithmic thinking. Let's take a look at one that's given people a little bit more trouble, and that is, where's that? I have too many files saved in this folder. Oh, it's down here, that's why. Oh, is that what I did? I think I got rid of it, moved it somewhere else. I was like, where'd that go? It's all right. I got it right here. Copy. That would explain why I can't find it. Okay, so let's take a look at one of these other problems, and that is one that gave people quite a bit of trouble, is the email assignment. Okay, so a lot of you got this far with it, where we had, the text, we split it based on the space, and then we had, for each word, we're looking for the at symbol, and we add it to an array. So in the end, if I have this array and I print it, I get all of these email addresses. But some of them, or many of them, have this extra garbage in here. And that becomes problematic for us because it prevents us from using those email addresses in an automated way. So how do we clean up the email addresses? This is a good application for an algorithm, but it also will help you maybe think about how we solve this problem. So if I have an email address, let's see, I'm going to get a test email address in here. Let's say I have that email address there, bill@bmoza.com. That's a valid email address. But let's say I have all kinds of extra crap in here. And some of this stuff is valid, right? Like this could be part of an email address, but we know it's not part of the email address because this is an illegal character. And same over here. So we know also that this is at the middle of an email address, not the physical center in terms of characters, but it's somewhere in the middle. We know that to have a valid email address, we have to have some stuff on this side of it, some stuff on this side of it. We also know that for an email address to be valid, it can contain letters, numbers, it can contain a period, it can contain a hyphen, contain an underscore, in addition to the @ sign. So anything that's not one of those characters is illegal. And we know that that's where the email address ends. But the hard thing is, how do we isolate those things? Okay, so here's what we do. We need to think through this in an algorithmic way. Okay, so when I'm dissecting this or taking this problem apart and making it into an algorithm, I want to say, starting with any email address, I know that I need to, for this part of it, go character by character until I get to an illegal character. I know that at that illegal character, everything past that is trash. Doesn't matter what it is, because this can't be in an email address. So when I hit an illegal character, that's the end, or a space. Same way. If I go this direction from here, then I know whether it's an illegal character or not. So I need to be able to take each part of this and look at those illegal characters starting at the @ sign and moving in either direction. Let's do this one first, the back half. So if I take this whole string and I split it here, I get an array with two pieces, this piece and this piece, index 0 and index 1. If I take index 1 and I go character by character until I find that and then stop and put this part into a variable, then I know that I have the last half of that email address solved. So let's get that far. So AR email equals split, and what we're splitting is str test email. Okay, so we're going to split that into the array. Str front is AR email 0. Str back is AR email 1. Okay, so now I have str front, this part of it, and str back, this part of it. So if I want to go character by character and see if it's legal or not, that's not too difficult. For another for loop will do this for me. For letter in, and I'm just going to design this as a function because I know I'm going to do the same thing to the front half in a manner of speaking. So def clean half, because I'm going to clean that half of the email. Str temp, I'll just use a temporary for that because it's only going to be inside this. For str letter in str temp, if I need a string to return here, so I'm going to put, as I go through, if it's clean, I'm going to put it in that string so I have something to return quite easily. So I'm going to do for each letter, if strlet, let's make sure it knows it's a string. So I can go is numeric, or I'm going to go is alphanumeric, or if str letter equals a period, because that's a legal character, or if it equals an underscore, or if it equals a hyphen. So now I've got, if it's alphanumeric, so if it's alphabet or a number, or if it's a period or an underscore or a hyphen, then we know it's a legal character. Str return plus equals str letter. Okay, so I'm going to add that letter to the string. So I'm going to rebuild another string letter by letter. And if it's not a legal character, then I can just stop, because I know that once I get to the point from left to right, I'm starting here, I'm going this direction. As soon as I get to here, I don't want anything else, even if it is a legal character. So this is where I stop, and that's why I'm putting a break in here. Just that half of it. Yeah, because I'm doing the back half right now. And then I want to return str return. Okay. So now I can, oops, over indented that. Don't want to do this. There we go. Okay, so I'm taking care of the back first. Now whatever I feed that clean half, I can do str back equals clean half, and I'm feeding it str back. So basically I'm giving it the back half of that email with all the garbage. It's going to clean it and send it back to that same variable. So now the back half is done, but here's the deal. The front half is a little trickier because I can't go this direction until I hit that because I'm going to get the wrong stuff. I want this, so I've got to go this way. So here's the trick. The first thing I'm going to do is create a reverse of that string, str front. And this is a little weird, but it just works. This is a string slice that basically says use the whole string, but do it in reverse. It just reverses that string. So I'm going to reverse str front, put it in str reverse, and then I'm going to say str front equals clean half str reverse. So I'm flipping the string back to front here and putting it in str reverse, which I'm then feeding to clean half and putting it back into front. Now the last thing I need to do is just print out the email address now. Okay, so I'm going to print, well, let's assemble it first. str whole email equals str front plus the at symbol, which I'm using to glue these back together, str back, print str whole email. Okay, so there's that. Let's run this. Uh-oh, index out of range. Why is the index out of range? Here's why. So when I go through, where is that? 24. Oh, my bad. Forgot the at symbol here. I was like, what's going on? There it is. I forgot I was going to split it out of space, and there are no spaces in that string. It needs to split it out the at symbol. There we go. Oops. Forgot one thing. Anybody want to tell me what it is? I forgot to reverse it back. So details, right? Okay, so str front equals str front, and the secret flip around code. That ought to do it now. And there it is. Okay, so that's clean now. So we've got that. Now I want to take all of this and I want to be able to apply it to the whole list instead of just my test case, right? So I'm going to comment that out. I've got my clean half function here, def clean email, and I'm going to let's feed it. I'm trying to decide right now whether I should feed it the whole array or if I should feed it the email. Let's go email. Okay, so email. Return str whole email. Okay, so now, just for kicks, let's test it with my test again just to make sure we're doing this right. clean email. STR test email should do the same thing. Okay, then we're in good shape. So now I need AR clean emails. I'm going to make a new blank array because I'm just going to clean these and stick them in there. For str email in AR emails, let's just make sure we're not conflicting with something else. Clean email. AR clean emails append. So we're going to clean that one and add it to that. And then we'll print AR clean emails. I'm going to comment that one out because I don't want it to print the individual email. So it should just print. So now that I've broken the problem down into pieces and I'm starting to put them back together, my end code is actually really short. And now I can go through and do a line-by-line comparison of each one of these, and they're all cleaned up. So that is how you would approach this problem from an algorithmic standpoint. And a relatively tricky problem, or seems like tricky, becomes pretty easy. You just have to take the problem and kind of break it down and test it, and there's some iteration involved. But if you pay attention to what you're doing and you really break things down into the smallest possible comprehensible chunks, you can do pretty well. So that is algorithms. And like I said, there's no assignment due for this, but for some of you who are still working on past stuff, some of this thinking structure and some of this methodology will make the approach to those a little bit easier. So that's why we're doing that. And the next topic that we're going to talk about on Wednesday is interesting to me, and it's an interesting computer science problem. It's called recursion, and it's basically creating a function that calls itself. So you've got infinite levels of, or potentially infinite levels of recursion, and Python actually won't let infinite recursion take place. But recursion is sort of a computer science problem that doesn't have necessarily a solution other than it's just something you can do. And sometimes it saves you some time, and sometimes it creates an elegant solution. But most of the time, it's just used to sort of explode computer science students' brains while they're trying to figure this stuff out. So we'll sort of dip our toe in the pool of recursion, but no assignment for that either. It's just something as you're thinking about computer science that you should become familiar with. So that's what we have to look forward to.